Hello class, welcome to our lesson today. This is a kind of a quick lesson dealing with the topic of vectors. I want to introduce a few things about vectors. It's not a huge portion of what we're dealing with trigonometry, but in case you have to take another class that deals with trig in some way, vectors is a topic that you may see. So this comes from section 7.4 and 7.5. I kind of morphed the two together. We're just going over some of the basics today with what vectors are and how they're represented and what they look like, how to graph them, etc. So let's go ahead and get started about what a vector is. A vector is something that includes a magnitude and a direction. So the magnitude, you can think of that as similar to a length or a distance, like from A to B, for example. And then the direction is which way it's going. Probably the one spot where you may have seen vectors outside of a science class or a math class is from the movie Despicable Me. Okay, the villain in that movie is called Vector, and he talks about direction and magnitude. So if you didn't understand what that piece was coming from at that point, it's because of the idea of what a vector really is in the mathematical world. Okay, the first thing we're going to deal with is just graphing a vector. So notice a vector A has a starting point and it has an arrow going in the direction. You want to make sure in these cases that the arrow is just showing which way the vector is going. But vector A, for example, starts at this location and then ends at the tip of the arrow. Okay, so don't think of this like a ray or a line, say a line with an arrow that goes on forever. It's showing the starting point. So here's B's starting point, and then it goes in this direction to the ending point. It's kind of showing you the direction of where it's going and how long that you're going that way. Think of it like a GPS. It tells you the route and it tells you how long it's going to take. So what happens here is we can use these graphs to help explain and draw out things like vector A plus vector B. So to do this, I just draw a vector A. So I just basically carbon copied vector A. But then from the end of vector A, then I pick up and move vector B and then draw vector B in this location. And then essentially you just put a starting point where you started and the arrow where you ended. So vector A plus vector B, essentially you're saying, well, what's the fastest way to get from A to B at that point in order to figure out what A plus B is. 3A is just a cookie cutter of A, and A. So notice that 3A is just 3 times as long than what A was. And then negative B basically says instead of going from one direction to the other, you flip-flop it. So it should look the same as what B does, except the arrow's going from the other direction now. And that's the only difference with negative B versus regular vector B. Okay, the position vector, vector U, U and V are typically used for vectors. You'll notice that the notation here is, think of it like starting at the origin and it goes to a point AB. You're going to use these brackets. They're kind of these like triangular brackets, not parentheses. So vector U has A comma B as its vector that we're looking at from that situation. And really all we're looking at here is to find things like the magnitude and things with angles, things of that nature. So the magnitude or length of a vector, okay, is just denoted, it looks like absolute value. Okay, so what you're finding, magnitude is always like the two lines like absolute value of the vector. And that's found by taking the square root of a squared plus b squared. The reason that vectors kind of relate to our trig stuff is that's how we found r, or the distance from the center to the edge, okay, of a triangle, okay, centered around the origin. And so really this is just Pythagorean theorem. So it's like a squared plus b squared and then equals c squared, and we got to square root it to find that distance. But because everything in trig and things like that are centered around 0, 0, we don't have to necessarily do the whole distance formula piece because the one of the numbers is going to be 0, 0. Then to find the angle, this is opposite over adjacent because b would be the y value, a is the x value. And so that idea would be tangent of theta equals that, and then we can use that to find the reference angle or find the angle of elevation, for example, or the angle it makes with the x-axis. All right, just some arithmetic pieces. It gives you vector u and vector v. So it says 3u, and it's as simple as just multiplying and distributing. So 3 times 3 is 9, 3 times 2 is 6, and you put the two brackets kind of on the sides like that, and that's the vector of 3u. Negative 4v is negative 4 times those. Notice that the negative switch it, so whatever direction it was going, now it's going the other direction. Okay, that makes sense because you're multiplying by a negative 4 in that situation, but it's just distribute and multiply through. Algebraically, you got 2v, so that'd be negative 6 comma 8, and then 3, 2, negative 6, and then plus 3 for 2v plus u is negative 3. 8 plus the 2 is 10, and then you have your brackets for the vector. Now the last one says magnitude of u. So remember, magnitude looks like the absolute value symbol. Okay, magnitude of u is the distance of, or how long that vector is. And it's just Pythagorean theorem, so it's just a squared plus b squared. So 3 squared plus 2 squared, and that equal root 13, or whatever decimal that you're looking at that needs to be found for that situation. So to recap, vectors have a magnitude and direction. Okay, we can find magnitude by using this formula right here, kind of like Pythagorean theorem. We can add and subtract vectors together algebraically, okay, by just adding their components together, or graphically, we can draw them out and figure out the final kind of starting and ending point of those situations. Have a good day, everyone.